Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about what is quality control or QC is. Quality control refers to the measures taken during experiment to make sure data are accurate and reliable. By applying quality control, we can reduce error and ensure the data we collect can be trusted. In short, quality control helps maintain the overall quality and credibility of experimental results.
Our mistake is ignoring quality control measures. So how it happens? First of all, not following standard operating procedures (SOP), skipping calibration of instruments, rushing experiments due to time pressure or lack of supervision, using expired, contaminated or improperly stored reagents. So it can affect like inaccurate experimental results, waste of chemicals, time and resources, and safety risks due to unnoticed errors and contamination. We can prevent this mistake by doing regular calibration and maintenance of lab instruments. Next, proper documentation and record keeping. Check and repeat suspicious results, and lastly, manage time properly. Quality control is important because it ensures accuracy and precision of experimental results. Next, detects errors early, such as instrument malfunction or contamination. Other than that, it improves reproducibility, allowing experiments to be repeated with consistent outcomes, enhance reliability and credibility of data and reports, supports correct decision making based on valid results, and lastly, meets academic, laboratory and industry standards.
We go to example number 1, which is using contaminated glassware. Okay, so the mistake occurs when glassware is reused without proper cleaning. For example, residual chemicals like sodium hydroxide in a burette will contaminate the next solution. So the effect when we use contaminated glassware or a glassware that is not cleaned properly is it will lead to inaccurate titration results. Second, it will shift the endpoint and lead to wrong concentration calculation. Third, it will reduce accuracy and precision of our result. And lastly, the errors become difficult to identify and cause wrong conclusions. For the precaution that we need to remember is before doing the titration, okay, make sure to wash with laboratory detergent. Second, rinse thoroughly with distilled water. The third is rinse burette 2-3 times with the titrant before use. For example, if we use sodium hydroxide as the titrant, then rinse the burette with the sodium hydroxide 2-3 times and then it is ready to use. Fourth is visually inspect for residues or droplets. Lastly, for the avoidance part, firstly, prohibit contaminated glassware in SOPs. Second, perform routine cleanliness checks. Third, store glassware properly to prevent recontamination. And lastly, follow good laboratory practice.
So, in this part, I will explain for the example 2, using data despite QC failure. For the first example mistake, in this situation, the QC results are out of range, which means the quality control has failed. However, the data is still reported anyway. This leads to inaccurate conclusion and unreliable result. Because the QC failure is ignored, instrument or procedural error may go undetected, and this can increase audit risk. Next, the precaution that should be taken. If QC fails, the experiment should be repeated under controlled condition. All procedure must be followed step by step, and everything should be properly recorded. Any corrective action, such as recalibration or procedure review, must be documented. Unusual results should be investigated, and guidance from experienced staff should be sought. Finally, how to avoid this issue? We should never use data from failed QC. Clear rules must be included in laboratory SOP. QC should always be checked before reporting result, and any anomaly must be fixed first. Training staff and students on the importance of QC is essential. Consistent QC help ensure data integrity and compliance with LGP standard.
Okay, now let's look for example number 3 in ignoring quality control in measures, which is lack of replicate measurements. We have 3 parts on this example, so I will explain about common mistake for this example, and then the precautions, and the last one, avoidance. One common mistake in analytical chemistry experiments is performing a measurement only once. For example, if we do a single titration reading, any random errors like misreading the burette or inconsistent mixing, it can directly affect our result. Without replicate measurements, these errors cannot be averaged out, which leads to inaccurate concentration values. By performing multiple trials, we can calculate an average and improve the precision and reliability of our results. Next, we move to the precautions. So, to ensure accurate and reliable results in analytical experiments, it is important to perform at least 3 replicates for critical measurements. This helps to reduce random errors and gives a more precise average value. Always record all measurements carefully and systematically, making sure nothing is missed. Follow a consistent procedure for each replicate to maintain uniformity. If you are unsure about any step, seek guidance from trained personnel to avoid mistakes. Additionally, any deviations from the expected procedure should be noted and investigated so that errors can be identified and corrected in future experiments. The last part is the avoidance. To avoid errors caused by lack of replicate measurements, it is important to include replicate measurements in laboratory standard operating procedures or SOP. Then, before finalizing results, always check your data for consistency to ensure that all replicates agree closely. Next, train students and laboratory personnel on the importance of performing replicates so they understand how this improves accuracy and reliability. Additionally, identify and analyze any variability between replicate measurements to detect potential sources of error and improve the overall experimental procedure.
To wrap things up, let's look at our final conclusion. Okay, we know that quality control is what makes our data reliable and accurate. We have seen that cutting corners to save our time will cause error that ruins scientific integrity and lead to wasted materials. Looking at the professional side, we can ignore that the risk of use failed data. In industry like cosmetic, ignore a result that are false as unpublished is a serious violation of laboratory standard. This doesn't hurt the lab reputation, but it puts consumer at risk. Because of this, quality control must be formal, non-negotiable part of our daily operating procedure. On the technical side, 2 specific standards are essential for precision. First, we have the triple rinse rule. If a tiny bit of leftover contamination like residue and alcohol can throw off an entire titration and lead to a one result. Second, we must follow the rule of 3, where taking a single measurement will lead to a blind or random mistake. So, by performing at least 3 replicates, we can spot outliers and ensure our final average is solid. In the end, quality control isn't just an extra labor, extra core in the lab. It is the only way to turn our raw number into trustworthy scientific knowledge. By sticking to this screening and testing protocol, we guarantee that our work remains a high standard by the global scientific community.